Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Subhan bin Muhammad Ashid. I have 3 members of one group, which is Akmal Hakim, Rafiuddin and Haziq Ishraf. Today, we will present about low pass filter and high pass filter in the topic of frequency response. In the first one, I will explain about the low pass filter or LPF. What is LPF? LPF is a low electronic circuit that allows low frequency signals to pass through easily and blocks high frequency signals. In simple words, it pass low and stop high. It is used to remove unwanted high frequency noise from a signal. So what is the main function of LPF? The main function of LPF is to clean up signals, which is sometimes a signal contains noise, especially high frequency noise. LPF removes that noise and keeps the only smooth noise, low frequency signal. This helps improve the quality of sound, data and electrical signals. Next, I will explain deeply about low pass filter. I will explain about the cut-off frequency. So, the cut-off frequency is the most important point in the low pass filter. It is the frequency where the signal starts to reduce or drop. Below the cut-off frequency, signals can pass through normally, but above this frequency, the signals becomes weaker and weaker. So, the cut-off frequency acts like a boundary between low frequency and high frequency. In the low pass filter, we have 2 types, which is the first one is inductive low pass filter, the second one is capacitive low pass filter. The first type is the inductive low pass filter. This filter uses an inductor, of course. An inductor allows low frequency signals to pass easily, but when the frequency becomes high, the inductor blocks more of the signal, so high frequency signals cannot pass through easily. Second type is the capacitive low pass filter. This filter uses a capacitor. The capacitor allows high frequency signals to flow to ground, while low frequencies signals continue their output. So high frequencies are reduced and only low frequencies remain.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haziq Ishraf bin Muhammad Aizal. I'm the second member of the group and I will explain about application, disadvantage and advantage of low pass filter. Application of low pass filter. First, the signal processing. Low pass filter are widely used in signal processing to remove high frequency interference or noise from signals, especially before sampling to in digital system, and it helps prevent unwanted frequency component from affecting system performance. The function is to suppress high frequency noise, smooth data or waveform used in communication and process control. Lastly, prevent aliasing before analog to digital conversion. Second point, power supply. In power electronic, low pass filter are used after rectifier or switching power supply to remove high frequency ripple and noise, producing a cleaner and more stable DC output. The function is to filter switching noise from power circuit, provide stable DC for sensitive equipment and improve voltage quality. Third point, noise reduction. Low pass filter help reduce high frequency noise with noise present in many signals such as electrical circuit and audio recording. For example, the noise is hiss sound, static sound, RF interference. The fourth point is audio system. In audio electronic, low pass filter are used to allow low frequencies to pass while blocking high frequency. For example, in speaker, crossover network and LPF send only low frequencies to subwoofer or woofer. The function is to direct best frequency to subwoofer, improve overall sound quality and reduce unwanted high frequency noise. Disadvantage of low pass filter. First point, potential signal loss. Potential signal loss, a low pass filter can reduce the signal strength. The reason is to the component such as resistor, capacitor or inductor cause energy loss. Some useful signal component may also be attenuated. For example, in communication circuit, the filter signal may become weaker and may require additional amplification. Second point, reduce high frequency. The reduced high frequency in low pass filter reduce or remove high frequency component above the cut-off frequency. The limitation of reduced high frequency is high frequency may sometimes contain useful information and removing them can reduce signal detail or quality. Third point is active limitation. Active low pass filter use operational amplifier and have certain performance limitation. It's common in limited bandwidth, require an external power supply, and performance depends on op-amp characteristic. Fourth point, transient response. Transient response refer to how quickly the filter respond when the input signal suddenly change. The issue is the LPF may introduce delay or distortion, and the output signal may take time to reach its final value. Last one, passive limitation. Passive filter use only resistor, capacitor and inductor. The limitation cannot provide signal gain, no application, performance affected by load impedance and may require large inductor or capacitor. Move on to advantage of low pass filter. First point, anti-aliasing. Anti-aliasing prevent errors when converting analog to signals into digital signals. Before an analog to digital converter, ADC samples the signal, low pass filter remove frequencies above the request frequencies. The result that the digital signal more accurately represent the original analog signal. Next point, the signal conditioning. Signal conditioning means preparing signal to electronic system that can process them properly. Next point, noise reduction. Many electronic systems contain unwanted high frequency noise. The filter remove high frequency interference and produce cleaner signal. Next point is flexibility active filter. Active filter use operational amplifier together with resistor and capacitor. It can amplify signals, easy to adjust cut-off frequency and can achieve higher filter order. Simplicity passive filter. Passive filter use only resistor, capacitor and inductor. It can simple circuit design, low cost, no external power supply required and easy to build and maintain.
Hello guys, my name is Muhammad Rafiuddin bin Rozaidi and I am the third member of this group. Today I will explain about high pass filter. Okay, what is high pass filter? A high pass filter is an electronic circuit that removes the low frequency part of a signal. It only lets high frequency signal pass through. The cut frequency, which is Fs, is the point where the low frequency start to be reduced. When a signal is reduced range, it's called an attenuation. By reducing the low frequencies, the high frequency can pass more clearly. A high pass filter helps remove unwanted low frequency noise, such as It is usually used in audio system, laptop, computer, and sensitive electronic device to reduce electrical noise that can affect their performance. Okay guys, let's go to the next slide. Okay, the next slide is a circuit diagram of high pass filter. The basic high pass filter is built by a series connection of capacitor and resistor. While the input signal is applied to the capacitor, the output run across the resistor. In a high pass filter, the capacitor blocks low frequency signal and allows high frequency signal to pass to the output. The frequency that separate low and high signal is called the cut-off frequency, FC. For your information, the high pass filter, there are 4 types. Firstly, passive high pass filter. The filter use basic component like resistor, capacitor, and inductor. They are simple to build, but they do not filter or select frequency very strongly. The second type of high pass filter is active high pass filter. This filter use amplifier to boost the signal. They provide better filtering and frequency selection, but their design is more complex. The third of type high pass filter is LC series resonator high pass filter. This filter use an inductor and a capacitor connected in series. The combination helps create a high pass filtering effect. Okay, the last of high pass filter types is microstrip high pass filter. These filters are commonly used in radio frequency (RF) system and are suitable for wireless communication device. Are you guys clear?
Okay, my name is Akmal Hakim bin Muhammad Min, and I'm the last group members, and I will explain about the application. Basically, we have 5 applications we will explain in this video. The first one is audio processing. We use in the speaker system to send only high frequency signals to tweeters, and with preventing damage from low frequency bass. Also, we use in mixing to remove unwanted low and rumble from recording. And the second one, basically we use in the signal processing and electronics, used in its sensor and control system to remove drift and low frequency disturbance. The third one, we use in image processing to enhance the high frequency details such as edge and the texture in the digital image. Okay, the next application we use in the biomedical engineering. Basically, we just filter out the low frequency noise and baseline drift in signals like ECGs, and ECGs electrodiagrams. And the last one is power supply. In the power supply, we eliminate low frequency noise induced interference in DC power supplies. Okay. Okay, next I will explain about the advantage and the disadvantage about the high pass filter. Okay. For the advantage high pass filter, the first one is noise reduction. Basically, high pass filter effectively remove low frequency interface such as the hum, rumble, and the 60 Hz noise. The second one is signal protection, which is prevent amplifier saturation or speaker damage from excessive low frequency and the high amplitude signals. And the next one, the third one is simple design, passive. Basically, it's generally simple to construct using basic component, which is resistor and capacitor. And the last one is no power supply. No power supply, passive. For the high pass filters, do not require an external power source. Okay, for the disadvantage high pass filter, we have signal loss, attenuation. Basically, passive filters often experience energy loss in the pass band. And the second one is a phase distortion. Basically, they introduce unwanted phase, unwanted shape phase near the cut-off frequencies, affecting waveform shape. And the third one is the component sensitivity. Basically, is the performance depends on precise component values which can drift. And the last one is active limitation. Active filters requires power and more complex and have limited bandwidth compared to passive types. That's all from us. We can refer our reference for the next slide.